Welcome back. Let's start with the covariance matrix in this. So what is covariance matrix? The covariance matrix provides a useful tool for separating the structured relationships in a matrix of random variables. This can be used to decorrelate variables or applied as a transform to other variables. It is a key element used in a principal component analysis. This is one of the MCQ's question, that what is the key element, like what is the use for the covariance matrix. So you can use that principal component analysis data reduction method, which is also known as PCA. Now, what is covariance we are talking about? So covariance matrix is always in, like, for example, it's 3 by 3 or it's 2 by 2. It's always in a square form. Okay, so it's 4 by 4, 3 by 3, like that way. So variance covariance matrix is defined as a square matrix. So it's always square, where the diagonal element represent the variance and the off diagonal elements represent the covariance. So on your diagonal element you will have variance, and off diagonal you will have covariance. The covariance between two variables can be positive, negative, and 0. Do remember this. This is very important, because this will help you in solving the questions where you will have the data science structures questions. A positive covariance indicate that the two variables have a positive relationship, whereas negative covariance shows that they have a negative relationship. If two elements do not vary together, then they will display a zero covariance. Now let's discuss with example. So this is the matrix you got. So this is 4 by 3 matrix, yeah? This one. So you have 4 rows, 1, 2, 3, 4, and you have 3 columns. Yeah? So this is 4 by 3. But your covariance matrix will always be square matrix. So you can see this. This one is 3 by 3. How to solve this? We have already discussed this in our previous example, the formula for covariance. So the covariance formula is summation of x minus x mean into y minus y mean divided by n. Now, if we have, so in this, you can see that, like, in the, if we write it in a descriptive form, on x, you have variance of x, which is your diagonal. So you can see that, that's your diagonal. My mouse is not great in creating these, but this is diagonal. Yeah, you can see this. And this is your off diagonal. So on your diagonal, you will always have variance. On your off diagonal, you will have covariance. Diagonal will always be, so x into x, you can see that. So variance of x. Over here, you have variance of y. Whereas when we talk about covariance, is covariance x of y, covariance x and y. Now, if we see this in 3 by 3 matrix, so this one is 3 by 3, yeah? So you can see that now you have x, y, z. So when we make this, so you can see that this is your diagonal, yeah, x, y, z. Now, x into x, y into y, variance of y, z into z, variance of z. When we talk about covariance, so you will write your covariance. The best way to understand this, so this is your y-axis, yeah, and this is your x-axis. So x of y, covariance of x of y. Over here you have covariance of x of y. Over here you have covariance of x of z. So this is your x, this is all your y, and this is all your z. When people usually get confused with x and z. So x is your, like, you're coming from your column, and your z is coming from your row. So you write covariance x comma z. In this one, covariance y comma z, because y coming from your x axis, like your column, and z coming from your row side, and variance of z. So this is how you do the covariance matrix.